Hello students, today we'll discuss IB Physics SL paper 1, May 2017, times on 1. You cannot use calculator in this paper. My name is Nariman Malim. I'm located in Baku. You can see here my mobile and email. Sources to prepare for exam: main huge textbook, short textbook, and you should have physics data booklet which include formulas. This booklet will be available for you on exam, and also physics IB physics guide which have syllabus and cites these formulas. This is a cover page of the exam. As we can see, a clean copy of physics data booklet is required. 45 minutes, 30 questions. Let's go on. Question 1. What is the unit of electrical energy in fundamental SI units? For any energy, it is equal to work done. Work done equals force times distance. Force equals MA, and MA is delta V over delta T. So mass kilogram, delta V over delta T meter per second squared, and meter. Combining meter and meter, we get answer C. Question 2. Which of the following is a scalar quantity? Answer is C. Kinetic energy, as all energies that has no direction, so it is scalar. An object is released from rest in gravitational field on Earth. Air resistance is negligible. How far does the object move during the 4 seconds of its motion? So here be very accurate. So during first second, this distance, during second, in 1 second, this distance, in 2 seconds, this distance, in 3 seconds, this distance, in 4 seconds, this distance. During 4 seconds, it is difference between distance travel for 3 seconds and 4 seconds. This is a trick here. They ask during the 4 second. So we use from section 2.1 and U equals 0, formula S equals GT squared over 2. Here I write the trick is that it is during the 4 seconds. So distance travel during 4 seconds, for 4 seconds, minus distance traveled for 3 seconds. G over 2 out of brackets. G is about 10, so G over 2 is about 5. 5, 17, 35. So we choose answer C. Next question. The graph shows the variation of speed v of an object with time t. Which graph shows how the distance traveled by the object varies with time? I have copied v over t over here. What we see? The speed is 0, then it increases, reaches maximum, then decreases, and again becomes 0. It is always positive. Actually, velocity is positive. So if we analyze distance over time graph, we should recall that gradient equals velocity and gradient is steepness. So I think that graph B suits the graph V over T. Why? Because gradient start at 0, so velocity 0, then it increases, then reaches maximum, then decreases, steepness decreases, and finally reaches 0. So answer B. Two boxes in contact are pushed along a floor with a force. The boxes move at a constant speed. Box X has a mass m, box Y has a mass 2m. What is the resultant force acting on Y? Here the tricky word is constant speed. Constant speed. You don't do anything. Constant speed, resultant force is 0. So we choose answer 0. Next question. Elevator, lift, and its load have a total mass so much and accelerate vertically downwards at so much. What is the tension in the elevator? Again, I have copied the elevator. I choose positive direction down. So two lift and mass, they have force acting down, mg, weight, and the force from cable, tension. Because it accelerates downwards, mg is greater than tension. And here we use formula resultant force equals ma. In booklet it looks F equals ma. So resultant force is mg minus t, and it should be equal to ma. Rearranging this formula for t, we get t equals mg minus a, then 750 10 minus 2, then you calculate, and you'll get 6000, which is 6 kilonewtons. Answer B. A graph shows the variation of force acting on an object moving in a straight line with distance moved by the object. Which area represents the work done on the object during the motion from P to Q? So points P and Q. Work equals area under the graph. Under the graph we have trapezium, and to find area of trapezium we should add area of triangle Y and area of rectangle Z. So Y plus Z, answer C. Question 8. A car traveling at constant velocity covers a distance of 100 meters in 5 seconds. The thrust of the engine is so much. What is the power of the car? So section 2.3 give us formula for power, which is force times velocity or speed. Velocity or speed equals distance divided by time. So here it is 20 meters per second. So substituting values and keeping kilo, we get kilowatt. Answer D, 30 kilowatt. Question 9. An elastic collision occurs between two bodies in the absence of external force. So here keywords are inelastic and absence of an external force. What must be true about the total momentum of the two bodies and total kinetic energy of the two bodies during the interaction? In elastic collision, by definition, means that part of total energy was lost, turned into heat or sound. Total momentum is conserved as no external force acts on the system. So we choose answer C. Only momentum is conserved, kinetic energy is not conserved. A liquid is initially at freezing point. Energy is removed at uniform rate from the liquid until it freezes completely. Which graph shows the temperature of the liquid, how its temperature varies with energy removed from the liquid? During freezing, temperature is constant, so we choose answer A, where temperature is constant during the process. A thin-walled cylinder of weight W, open at both ends, rests on flat surface. The cylinder has height, average radius, thickness. Thickness is much greater than x. So R is much greater than thickness. So thickness is negligibly small. What is the pressure exerted by the cylinder walls on the flat surface? So pressure equals force over area. Here force is weight. Area of contact is area of big radius minus area of small radius. So PR squared simplified. 2 pi Rx has some value, but x squared is much less value, so neglected. So we substitute these values and we get answer A. A fixed mass of ideal gas in a closed container with movable piston initially occupies a volume V. The position of the piston is changed so that the mean kinetic energy of the particle in the gas is doubled and the pressure remains constant. What is the new value of volume? Section, I'm very sorry. Here we are. Right. So section 3.2, ideal gas formula PV equals nRT. We rewrite it for V. So here we should know what happens to temperature as pressure doesn't change. Temperature. To learn about temperature, we use this formula for average kinetic energy. So average kinetic energy doubles, it means that temperature also doubles. So temperature doubles, volume doubles, so we choose answer 2V. We choose answer 2V. Question 13. A particle undergoes simple harmonic motion. This graph shows the variation of velocity of the particle with time. What is the variation with time of the acceleration of the particle? Again, I have copied V over T over here, and gradient is steepness, and here gradient will be acceleration. So what we see at the beginning, acceleration is 0, then it is positive, 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 reaches maximum, then positive, 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 goes to 0, and then becomes negative. So graph A. So 0, then positive, reaches maximum, and then, so neither other graph behaves this way, so it is A. What statement about X-rays and ultraviolet radiation is correct? So we go one by one. A. X travel faster in vacuum than ultraviolet. Wrong. They all have the same speed. X-rays have higher frequency than ultraviolet. Yes, it is very dangerous and high frequency. So we choose B and we ignore the rest. Two pulses are traveling toward each other. What is a possible pulse shape when the pulses overlap? So when they overlap, they will be identical, and we use principle of superposition. So total displacement will be sum of displacements. So it is doubled. So it is A. Unpolarized light of intensity I0 is incident on the first of two polarizing sheets. Initially, the planes of polarization of the sheets are perpendicular. Which sheet must be rotated and by what angle so that the light of intensity so much emerge from the second sheet? This is complicated. So section 4.3 give us what happens to second going through second polarizer. Remember, first polarizer decrease intensity 2 times. Second, by formula, this formula, Malus formula, and because angle is 90 plus angle of interaction, we convert it into this expression to see whether it works or not. Then we have A. First polarizer factor 1 over 2, second polarizer 1 minus cosine squared, cosine minus 1 square root of 2. So this gives us 1 over square root of 2, cosine squared gives us 1 over 2, 1 over 2, 1 over 2 gives us 1 over 4. But here the choice is 1 only. Why not second? Also we can change, rotate either 1 or 2. So we straight go to from A to C, which has the same angle, but it gives us more choices, 1 or 2. So we choose C. If you are interested for D and B, you will get 3 over 8. Question 17. When sound wave travels from a region of hot air to a region of cold air, it refracts as shown. What changes occur in the frequency and wavelength of the sound as it passes from hot air to the cold air? So wave equation, C equals F lambda, lambda equals C over F. F doesn't change. So how many waves come every second, so many waves go every second, so frequency doesn't change. From section 4.4, I have this Snell formula linking angles and speed. we see that angle decreases. Angle is between normal and the ray. So angle decreases, it means the speed decreases, and as speed decreases, wavelength decreases. So we choose answer B, frequency unchanged, wavelength decreases. The graph shows a variation of current with potential difference for a filament lamp. What is the resistance of the filament with the potential difference across is 6 volt. So we use graph 6 volt. 6 volt corresponds to 9 volt, 9 milliamperes. So we copy this information from the graph. V equals 6, I equals 9 milliampere 10 minus 3. Resistance is always voltage by current, and you should get this expression. 670, 10 minus 3 becomes 1000, 6000 over 9 will give us this value. Question 19. Electron is accelerated through a potential difference so much. What is the change in kinetic energy of the electron? From section 5.1 we know that potential difference equals work over charge. It means that work equals charge by potential difference. So potential difference is so much. Charge of electron we get from booklet. So energy change equals work done, and substituting the values into this formula, QV from booklet, given value mega 10.6 again from booklet, we get 10 minus 12. Booklet says that it is pico, so we change it into pico and we get answer C. Question 20. A cell is connected in series with a resistor and supplies a current of 4 amperes for a time of 500 seconds. During this time, 5.5 kilojoules energy is dissipated in the cell and 2.5 in the resistor. What is the EMF of the cell? Here I give two versions. One version is without big understanding what is happening. So section 5.1, EMF equal potential difference on external plus potential difference on internal. They give us energy. Formula for energy, I squared RT. It means that IR will be 1.5 divided by IT, but IT is charge and we can calculate this charge. The same for IR when R is big. Let us make it big. When R is big, so we get these two fractions, and then we just using this formula add these fractions and we get 2. Answer D. Version D tells us then how much charge has passed. By definition of EMF, it is energy per 1 unit charge. So if charge Q, total energy will be QE, and it is equal to the sum of energies dissipated in both resistors. So we divide by charge and we have the same calculations. Done. Question 21. Electron traveling at speed v perpendicular to magnetic field of strength B experience a force F. What is the force acting on alpha particle traveling at 2v parallel to magnetic field of a strength 2b? Pay attention to these keywords. Parallel. Very, very complicated, but this parallel kills everything. So section 5.4, F equal QVB sine theta. So if theta equals 9, sine equals 1, but if theta equals 0, sine equals 0. So for parallel we have 4, 0, which is answer A. Question 22. A horizontal disc rotates uniform at constant angular speed about central axis normal to the plane. Point X is at distance 2L from the center of this point Y at distance L from the center. Point Y has a linear speed v and centripetal acceleration a. What is the linear speed and centripetal acceleration of point X? Very easy. Section 6.1, formula for velocity omega r. So if x is 2L distance, then v equals 2 times greater. Formula for acceleration should be rewritten, so we substitute v here, we get a equals omega squared r, again linear relation, 2 times increase of r, 2 times increase of a, so we choose b, 2v to a. Questions 23. An object of constant mass is tied to the end of a rope, length L, and made to move in a horizontal circle. The speed of the object is increased until the rope breaks at speed v. The length of the rope is then changed. At what other combination of rope length and speed will the rope break? Okay. So we check one by one. So if length is 4, speed is 2, then we get the same mv squared over r. So formula from section 6.1 for centripetal force. So we choose answer A. A nucleus of phosphorus decays to a nucleus of silicon with emission of particle X and particle Y. And what are particles X and Y? So we should have top and bottom numbers balance. As a result, we get here 1 0, here 0 0. 1 0 is positron, and because it is positron, this should be neutrino. So antiparticle should be accompanied by particle to have lepton number constant. So answer D. What is the definition of unified atomic mass unit? So it is A, just learned by heart. It is 1/12 mass of neutral atom of carbon 12. So protons and neutrons mixed and average of it. Right, in a nuclear fission, let's move a bit. Right, okay, we'll move later. Question 26. In nuclear fission, nucleus of element X absorbs neutron to give a nucleus of X, to give a nucleus of element X and Y, a nucleus of element Z. So we have fission. X absorbs N and splits into Y and Z, and we have 2 neutrons. What is the ratio of magnitude of binding energy Y by binding energy X, total binding energy YZ, and total binding? So let's look to this diagram. How binding energy depends on atomic number. So X is here, it has less binding energy per nucleon. This is why it can split into Y and Z. And during splitting, energy is released. It means that total energy of Y and Z should be less than X. And per nucleon, it is obvious that Y has greater binding energy. So we're returning here, we choose A. Greater this and this. Right, okay. What is the energy equivalent of the mass of 1 proton? So first we use formula for energy equivalent. So energy is associated with mass by formula E equals mc squared. It is famous Einstein formula from booklet. Booklet, I mean mass of proton, I took from booklet. Speed of light I took from booklet. And this is 3 squared 9. This is about 2. Estimate 2 by 9 give us 18, 10 minus 11. So estimate with one significant figure. Now let's check. So A give us this is about 10, and this is 10 6. So 10 times 10 6, 10 times 10 6, and then the same factor as we have here. So as a result we say no, because by order it is different. Now here 10 times 2 20, 10 minus 19 by the same factor. We compare, no. Now here 10, this is about 2, so 5, 10 minus 11. Again here we should say no, I think. Okay, let's wait, because it is now close. It is 18. And if we look here, 10 times 2 20, 10 minus 11, 20 minus 11, here 5, here 20. Which is closer? D is closer, so we choose D. Finished. Question 28. The following are energy sources, so battery, crude oil, pump storage, which are secondary. So crude oil is primary, we exclude 2 and we get answer B. Question 29. Planet X and Y both emit radiation as black bodies. Planet X has a surface temperature that is less than the surface temperature of planet Y. What is the graph of the variation of intensity? The graph of X is shown dotted. So X is at lower temperature. We use section 2.8 formula for power and maximum. X has less temperature, less power, less temperature, greater lambda. So this graph corresponds to greater maximum, lambda maximum for dotted, and we choose D. Question 30. The average surface temperature of Mars is approximately so much, Earth so much. Radius of Mars is half that of radius of Earth. Assume that both mass acts as black body. Find the ratio of power by power. Again, section 2.8, but here we take into account the area, surface area, which is 4 pi r squared. So we find ratios that they want. When you divide ratios, you divide factor of radiuses, and factor of radius will be squared and temperature will be to the 4th power. So radius is 2 times less, temperature is 200 by 300, 1 over 4, 16 over 81, 81 is about 80, so 4 over 80, 120 is 0.05. Paper is over. Thank you very much for your attention.